Good morning, students. So today we study about the combination of the resistance in series. So yesterday lecture we study about the parallel combination of the resistance. So in parallel combination, we derive the formula parallel combination of resistance is equal to what is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula of a resistance in parallel combination, and where Rp is equal to equivalent resistance of the parallel combination. Equivalent, or we can say this is total resistance. And where R1, R2 and R3 are resistance of circuit. So we can find out here total resistance of a circuit using this formula. So we take a numerical like this is a parallel combination. So here what is, this is applied voltage V, and here 4 resistance given. These resistance are R1, R2, R3 and R4. Okay. So here R1, R2, R3 and R4 resistance. For example, this given 4 ohm, and this is also 4 ohm, and this is also 4 ohm, and this is also 4 ohm. So find out the total resistance of the circuit. So this point A and B. So we can find out total resistance by using this formula. So what is 1 by Rp is equal to 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. So here we take LCM. So this is equal to 4 by 4. This is equal to 1 ohm. So here 1 by Rp is equal to 1 ohm and Rp is equal to 1 ohm. So this circuit can be replaced by a single circuit like so. AB and this is equal to 1 ohm. So these both circuits are same, and we can found easily value of a equivalent resistance by using these resistance and these formula. So this is important formula to determine the resistance of the circuit. So in previous lecture I tell one numericals, that numericals this and applied voltage here V, and this resistance R1, R2, R3 and R4. So here this value what is 10 ohm, this is 20 ohm, this is 10 ohm and this is 20 ohm. So here this combination example of a series combination. So in previous lecture I tell we use that parallel formula. So parallel formula not applied. here apply we series formula. And what is the series formula? Rs is equal to R1 plus R2 plus R3 plus R4. So because this is a series combination, series combinations. So how we determine this is a series combination? Because when current flow, so current flow only one branch, here only one branch. So here only one branch, so current having same path, so that is why this is a series combination. So if we put here this value, so if here we use this value, that is 10 ohm plus 20 ohm plus 10 ohm plus 20 ohm. So this is 30, 40 and 60. So what is total resistance? 60 ohm. So this is a series combination. Okay. So series and parallel combination both have different formula. Here question is how to determine this is a series combination and this is a parallel combination. So simply in parallel, current is divided into different parts like this. So here total current I, and this I divided into three parts. So this I divided into three parts. This is I1, this is I2, and this is I3. So that is why this combination is a parallel combination. So here we apply this formula, Rp is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. If there only one path, so this is a series combination and we apply this formula. So in yesterday lecture, we already derived this formula. So here we derive the formula of a series combination. So how to derive a series combination? We take a circuit. So for example, so these are three resistors are connected in series. So here what is R1, R2 and R3. And here we connected what? So this is what is voltage. So this is voltage and this is what is ammeter and this is what is switch. So this is switch and this is what is ammeter. And these are resistance or a resistor. So here we also connected a voltmeter to measure the electric potential. So here how to connect a voltmeter? So we know voltmeter always connected in parallel combination, because in parallel combinations voltage is same. So here what is this? This is voltmeter. So this is voltmeter V1, this is voltmeter V2 and this is voltmeter V3. So this circuit is complete for the derivation of a resistance in series combinations. So here what is this? This is ammeter to measure electric current, and here switch is what is function open or close. And this is voltmeter to measure potential or voltage. Because potential, electric potential, voltage difference are same things. So we can write here potential or voltage. So this is a complete circuit. So first of all, we write here what is R1, R2, R3. R3 resistors are connected in series with a voltage V. So this is total voltage. So we write here R1, R2 and R3, three resistors are connected in series with voltage V. So here total voltage V divided into three parts, V1, V2 and V3. So we write here V is equal to V1 plus V2 plus V3. Because applied voltage are divided into three parts, V1 taken by resistor R1 and V2 taken by resistor R2 and V3 taken by resistor R3. So that is why we write here total voltage is equal to V1 plus V2 plus V3. So we know V is equal to IR. So this formula comes from the Ohm's law. So according to Ohm's law, V is equal to IR, and we can write also V1 is equal to what is current here same. Here current I. So current through the circuit is same because only one branch. So current is same. So here current is same. So this is what is series resistance and this is total voltage and this is IR1. V2 is equal to IR2 and V3 is equal to IR3. So this voltage is equal to product of a resistance and voltage. So these value V1, V2 and V3 put in equation this. So this equation 1. So we put these value in equations and we get so if we put here value V is equal to IRS, V is equal to V1 plus V2 plus V3 and V is equal to here what is value of a V? IRS. So here we put so here IRS and put here value of a V1. So V1 what is IR1. So this is equal to IR1 plus IR2 plus IR3. So from this equation we take I common. So here I into RS is equal to I taken common R1 plus R2 plus R3. So R1 plus R2 plus R3. So here I to I cancel and RS is equal to R1 plus R2 plus R3. So this is the formula of a resistance in series combination. So this is equal to R1 plus R2 plus R3. If we add more number of resistors, for example, here we add one more resistor, this is R4. So here voltage what is V4. So we can modify this formula by this is R4. So if we take n number of resistors, so here we add Rn. So this is depend upon the how much resistor in circuit. So according to that, we use that formula. If 3 resistor given, so 3 resistors are defined in term of formula. If n number of resistors are given, then we use n number of a resistance. So here this is the parallel combination, this is the series combinations, and we derive the formula of a resistance in series. So in next, we study about the domestic electric power supply and other numericals on basis of the resistance. Thank you very much.